Good afternoon. Yes, great. So thank you very much for choosing our session. So this is future use cases. So in many of the sessions so far, we've heard a lot about the architecture, the different tools, services of EOSC, and now we're getting to the really important part, looking at the use cases. So we've got two sections. We've got a section on scientific use cases, where we'll have two amazing speakers, and then we'll have a section run by Marchan on the business side of EOSC with two more amazing use cases. So let's kick in and get started straight away. So within the EOSC Future project, which some of you may have heard of already, one of the key parts of this was looking at science projects. So how different communities really can make use of EOSC and really use it for their own, set up the environments in order to help their particular different communities to use the EOSC from a scientific perspective. So we've got two particular science projects that will be presenting their results and how they have been using the EOSC. So I'm very happy, yes, to welcome from the PANOSC. So this is the photon and neutron community, or PAN community. I'm very happy to welcome Miguel A. Gonzalez from the Institute Laura Langevin, or ILL to his friends, and he's going to be talking to us about tracing biostructures and dynamics of biological processes. So Miguel, over to you.
Thank you very much, Sally. Sorry. Good afternoon, everyone. So as Sally just said, I'm coming from the ILL. This is a nuclear reactor in Grenoble, which basically we are producing neutrons. It has been the neutron reference facility for more than 50 years until now. It will stay for a few more years until the new spallation neutron sources starts operation in Lund very soon, hopefully. And then I'm going to talk you about the PANOSC user case. So I suppose that most of you are not aware of what PANOSC is. This stands for Photon and Neutron Open Essence Cloud. This was a European project where basically we tried to develop the data policies, the infrastructure, the tools to make our data as fair as possible. And this project applied only to multinational facilities, so this was complemented with spans, which applied also to the national facilities. So basically, we are talking here about the full photon and neutron community in Europe, which we collaborate together in two different associations. One is LENS, the League of European Neutron Sources, with the members that you can see in the figure on the left, and the other one is LIPS, so the League of European Advanced Photon Sources, with all the members that you can see on the right figure. So here you have a few numbers. I will not go through all of these. Just two key figures. For the neutron science in Europe, basically we have 10 facilities and a community of about 5,000 users. And those numbers are even bigger for the photon and science. Basically, for the synchrotron and free electron lasers, we have like 19 facilities now and a community of more than 35,000 researchers. So this is quite a large community. But I will say the main challenge that we have is that we cover many different aspects of science. A little bit different from what I have seen until now. We had a great talk this morning about the oceans. In the previous sessions, I was hearing about cancer, COVID, and these kind of things. The problem is that we just provide the tool. So the tool, the neutrons or the photons, and then basically our users, they come with their samples, they come with the science, and they do whatever they want with the data. So here, for example, you have a figure coming from a single facility. This is the French synchrotron Soleil, close to Paris. And this is the publications in 1 year. So you can see the main domain in that case, or the main larger number of publications come from the protein crystallography. But there are also very important domains in material science and looking with electronic transitions, structure phase transitions, also geology, cultural heritage, particle physics. So as you can imagine, it is impossible to cover this with a single tool. Each community, they have their different tools. And basically, we cannot provide a single answer to all of them. Coming to fair data, in the last few years, we have progressed nevertheless quite a lot. And I will say that nowadays, whenever we do experiments, We fulfill the fair data principles to a large extent, in the sense of storing the data, having the data policy, having the data available to the public. This also applies to the metadata and the experimental data in most of the cases. As you can see, I have put a question mark there. There are some exceptions. This is basically when it is the user team who comes with their own equipment. Sometimes they have with their own equipment to control the humidity, the temperature, whatever variable. And in these cases, they are not always integrated with our acquisition software, and those data, they are all available to the people that did the measurements. And then our biggest issues come when we start to talk about the sample. Quite often, to do a proper data reduction, proper data analysis, we need to know a lot of things about the sample, how it was prepared, how it was synthesized, concentrations, these kind of things. And the level of information that we have depends, of course, on the seal of the experimental team filling this information. And finally, we may have also, in some cases, to need additional data to do a proper data analysis, which could be measurements that are done before or after the experiment, that are done in other facilities. And of course, almost in all cases, this is not available and this is not stored with the data that we obtain at the facilities. So this is the challenge that we have, and I must start by confessing that we are not still tackling this challenge. For the EOSC Future program, we just focus on a very specific aspect, which was, as Ali said, the analysis of the variability and the different conformations that proteins can adopt, which can be studied with a small angle neutron or a small angle X-ray scattering. So this is a sketch of a typical experiment. The experimental team will have a protein of interest for them. Typically, it will come with the protein in a solution, and we will send a neutron beam or a photon beam to the sample. It will scatter in our detectors, and you will get images like the ones that you see here, which after data reduction and analysis provide curves like this. And those curves basically contain information about the size of the protein, the shape of the protein, and also about the variability of the protein. The protein is not a rigid structure, it can change. And basically, we can use this information to study the different conformations that the protein will adopt in solution. The reason that we chose this system is that we have already two important pieces of information that we can work with. So one is those protein data bank structures. So there is a database, public open database, that contains already hundreds of thousands of structures. Typically, they are static images of the protein because they are obtained in many cases using protein crystallography. So this is the protein in a crystal structure. It's not quite often the same structure that the protein adopts in solution, but it's a good starting point to start our modeling. And the other important piece of information is that we already have a database of reduced data, which have been properly treated, properly analyzed. So basically, they don't depend on the conditions of the experiment, they don't depend on the instrument, and we can already start to work directly with those data. So the idea, of course, for expert users, they can go directly this, take those data and work with those data. There is no problem. But new users or people that are coming from other communities, which are non-scattering experts, they will say, okay, how can I get useful information from this? So our goal was to provide an easy workflow, basically in the form of a Jupyter notebook, that finally will allow them to obtain images, visualizations of the protein, and important information for their own purposes. So to give you a quick glimpse of how this will look in practice, this is the demonstration that I just saw in the consortium meeting yesterday. One user will log into the EGI replay service. So this is available to all the European researchers. In my particular case, I will log in using the umbrella, which is a federated authentication for photon and neutron users, but there are many other possibilities. And one will launch a binder machine containing already everything that we need there, and have this kind of information, different notebooks that one can use to explore, to train a new user, for example, to see how the tools work, and in this particular case, for example, to try to reproduce a paper that has been published. So this is a recent publication. It was already a round-robin study of 5 different systems. Basically, the goal of this study was to determine the reproducibility of the structures obtained in different facilities, basically to to determine how reproducible are the data when we use different instruments to obtain it, when we use different reduction software to get a result. So we have those 5 structures. Directly from the paper, we can get the PDB codes and load it immediately. Easily, then we can visualize the protein, see how it looks like, play with this. We can also look to the calculated profiles, starting with this structure. And then, of course, what you obtain will be different if you measure with a probe or another. So the signal will be different if you measure with X-rays or with neutrons. Neutrons are very, very sensitive to the hydrogen or deuterium. So we can also measure the same protein using either a deuterated solvent or a normal water solvent, and we will produce different results. And then we can start playing with the data, comparing the profiles obtained given by the different proteins, checking what will happen if we hydrogenate or deuterate different parts of the protein or the solvent, and then start to model our system. So as I said at the beginning, the starting point is a crystal structure reference of the protein, but the protein is a flexible object, so we have modeling tools that are using the flexibility of the protein allow to determine or to generate tens or hundreds of conformations. So we can generate them. You can calculate the profiles for each of those, determine which are the most likely one, then comparing to the experimental data. And even go beyond and basically obtain a dynamical image of the system, basically by fitting those models and getting more complex models, which basically is a combination of different conformations, because again, the protein is not a static object. So then we can simply get a full comprehensive output, plot those results, save them, and use them for further analysis, further use. And we are just starting with this, but of course, one of the goals will be that this will be important for the health of the pharmaceutical communities, for example, to determine which is the shape of the protein, which kind of drugs could assess part of the protein. And they typically do this, as I said at the beginning, using those crystallographic references, but this will provide more pertinent data for them. So, yeah, I think I'm quite good on time, because this is already my last slide. My main message will be that now photon and neutron facilities are committed to fair principles and open data. As I said at the beginning, the main challenge is the diversity of the communities that come to our facilities to use them. So we are working, let's say, on more the psychological aspect to try to convince them of the need to go in these directions. Several facilities already, but not all, but at least the main facilities have already onboarded the data repositories, and they are available into the EOS marketplace, together with the infrastructures to work and analyze the data. This is something that we will need to study at the moment. The data, the data portals and the facilities are available in the marketplace, but they all require to have a user authentication in the facility, in the corresponding facility. The big challenge that we have is the diversity of science. And then, well, basically, as I said, we are trying to work with the users to incentivize, to improve the sample description, to provide them the tools also to make this easily, and to convince them of the importance of having fair data. So what we develop in the EOSC Future case basically is a proof of concept for a well-defined case. And now we hope that will be the seed for further developments in this sense, and that we can extend it to other communities. Here I am just mentioning a few: powder diffraction, spectroscopy, materials science, but hopefully this will be just the first step of similar efforts in the near future. So with this, I just finished. Thank you very much for your attention. And
thanks very much indeed, Miguel, for making photons and neutrons simple and reproducible. So great. Thanks very much. So now I'm delighted to hand over to Angeliki Adamaki, who works at the ICOS Carbon Portal Research Infrastructure at the University of Lund in Sweden. And Angeliki will be telling us about the dashboard on the state of the environment. So over to you.
Thank you, Sarli, for this introduction. Hello, everyone. Of course, I don't just represent ICO's Carbon Portal in this presentation, but I'm a group of research infrastructures from the environmental cluster. So I'm going to talk about the dashboard for the state of the environment, which is a service designed, developed, and supported by the environmental research infrastructures for the EOSC Future project. Remote control challenge accepted. So this service that we have developed, it has the form of a dashboard, which means it has different frames that provide a collection of environmental indicators that result from fair data and services provided by the ENRIs. By fair, of course, we mean findable, accessible, interoperable, and reusable. To access the service, you can simply scan the QR code that you can see here, which corresponds to the link of the service. What are the characteristics of this service? First of all, it is an EOSC service, backed by approved EOSC providers, which are the research infrastructures that provide the data and the services, but also the quality assurance of the data and the sustainability of the services. The dashboard has a flexible setup. It provides near real-time data, and it has an architecture that allows it to continue growing as it collects more indicators from more providers. Thanks to the technology in place, all of you as EOSC users, you can customize, you can tailor the dashboard to your needs, and by logging in with your EOSC credentials, you can save your personal dashboard and you can create your own profile. In this project, we collaborate with well-established organizations, as is the SysDataNet, ICOS, Actris, IAGOS, and ELTER. We have the development and the maintenance of the central service supported by EMSO. And we also have the Marine Data Viewer, another service that you will also see in a bit, which is developed by Maris. Several EOSC services have been used in order to develop the dashboard. These services include the Marketplace, the AII Federation, services for storage, monitoring, and help desk. All of those services are crucial for the development and the support of the dashboard. To understand the motivation for this project, we have to think how data science empowers scientists in earth and environmental science, but also policymakers, to make well-informed decisions, to observe and understand nature, to study the results of human activities on the climate and the environment. So data science in this context involves a spectrum of activities. We have data collection, we have data analysis, modeling, hypothesis testing, we have the development of warning systems, in general, advancements in ecological research. We have policy making based on risk assessments, open science practices, transparency, collaboration. All of those activities stand in the core of environmental data science. But let's try to bring an example so that we can make it more clear. Air quality. Here we have scientists, we have policymakers. We have people who need tools in order to develop policies for sustainable transportation, for example, in order to improve air quality monitoring, to support urban planning strategies that don't harm the environment, and many other topics that are related to air quality. The question is, how can the EOSC and the service like the dashboard support this kind of topics and actions? When you visit the service, you will see the interface, which has, as I said in the beginning, these different frames, each of them providing the environmental indicators from the different research infrastructures. Those indicators are either some numbers, as you can see here in these frames, that result from measurements that are provided here by the infrastructures that come from stations that are placed somewhere in Europe. In this case, since we have the air quality, the dashboard gives a set of environmental indicators from the atmospheric domain. So thanks to the dashboard, you can see concentrations of CO2, for example. you can see near real-time black carbon measurements, ultrafine particles, or concentrations of, for example, the ozone at European airports. By interacting with the frame, you can choose to preview. There is a preview button on this frame. And with this, you will be directed to the supporting services behind the dashboard, which in this case, it gives you the time series as this is provided from the measuring station and the supporting infrastructure. Another example from the marine domain, coastal management. Here again, we have scientists and policymakers who want to address challenges of climate change. They want to help preserving the marine ecosystem, but at the same time, they want to support economic growth in coastal regions. What can we do here? In this case, we have indicators from the ocean domain. Those you can find on the frame that brings the logo of SeaDataNet. The marine domain indicators, they have the form of graphs of plots where you can see you can choose from a drop-down menu to visualize the different indicators that can be, for example, annual temperature, seasonal temperature. You can choose the area, Eastern Mediterranean or Western Mediterranean. Or you can interact with the frame again by clicking on the SeaDataNet logo. And you get, in this case, you get access to another service, which is also developed for the EOSC Future project. And this is the Marine Data Viewer. In this case, you have the option to visualize any of the essential ocean variables as those are defined by the marine domain. On a map, you will see a global map. Here I have zoomed in to show only Europe. And you can see, for example, in this case, temperature measurements that result from satellite and in situ measurements. Or you can plot oxygen or other variables. And you can change, of course, the depth of the seawater or the time where you want to see the results. So what do we have so far? We definitely have a complex landscape of science and technology. We definitely recognize the need to support interdisciplinary research. Cross-domain research, cross-domain activities need to be supported by tools. They need to be supported by scientific platforms like the EOSC. So what we have to do is to embrace interdisciplinary research. We have to facilitate data sharing across disciplines. We need to foster collaboration and communication. The EOSC platform is crucial to enable all of these advancements. And we, as the ENVRI community, aim to support this mission by contributing what we do and know best, scientific knowledge. So this story that I just told you is also published in this booklet by the project. It's recently published by the project. So the title is EOSC in Practice Stories. And our story is number 25, but you can find also other use cases. And you can also, of course, find the dashboard by going to the EOSC portal. And if you type environmental indicators or state of the environment in the search engine, then you can find in the category of the services, you can find the profile of our service in the EOSC portal. And then you can access the service by following the instructions on the portal. So with this, I thank you for your attention. And I invite you to also visit the ICOS booth at the exhibition. Tomorrow, during the lunch break, we can give you a demonstration live on the dashboard. Thank you.
Thanks very much indeed, Angelaki, for this. This is fantastic. Seeing how environmental data science on air quality, marine indicators can be helpful for both interdisciplinary research and policy making. Fantastic. So we've got a couple of minutes for questions on the scientific use cases before we move on to the disciplines. So are there any questions in the room or online? No, none online yet. So who is going to ask a question? So over to Matt, I think, first, please.
Question for Miguel. You said that you were looking at ways to open up the data and resources to non-authenticated users. I'm just wondering what the barriers are that you're currently facing which stop you doing this.
Good question. I will say two different things at two different levels. At the data policy level, I will say it's mainly psychological barriers. This started maybe 15 years ago, I think we started with the data policy. At the time, there was even a lot of discussion between the scientists at the facility already. Because from what I explained, I mean, the fact that this is the external users who have an idea, who come with their samples, there's also their feeling that there is their own science. So in fact, all the data policies that we have an embargo period. The data are only available to the experimental team for 3 years, which they can request extension to 5 years, before becoming public. The first public data, this was, I think it was already, maybe something like 5 years ago. Some of them have been used. There are difficulties to reuse those data related to what I explained. A lot of the analysis depends on the metadata associated to the data. So this is one thing. So there was a lot of discussion how those data will be used, how people who has no experience will use the data, if they will be wrongly used or led to wrong conclusions. So I would say this is one of the aspects concerning the data itself. So at the moment, this requires basically everybody can become a user, or at least having a user account, but there is some kind of control. So I would say this is one of the things. And for the moment, I'm not sure, if it's not in my hands, I'm not sure that the data will become publicly open in the sense that, well, they are there and no matter who can take them. The other thing is the infrastructure, computing resources, software that you need to handle them. In some cases, is relatively easy. The case that we saw here, we don't really need very, very big resources. In other cases, it's not the case. And then, of course, it's the matter of the available resources. We already have some problems in some cases with the schools when we have several 20, 30, 40 people trying to use heavy resources at the same time. And let's say our own resources are not available to really cover a much larger user cases at a given moment.
Thanks very much. Mark has a question. Thanks.
A question for Angeliki. You showed us this very nice dashboard with combining data from all different sorts of projects and sources. So I'm just wondering what sort of standards and protocols are behind the gathering of that information. Are there some standards behind there?
You mean the question is about the metadata standards, for example, or what kind of...
whatever standard it is that allows you to get that data from that external resource and then integrate it into your dashboard.
So basically how we worked in this project. So we have the research infrastructures. As I said, all of them well-established organizations. They have their own data and they have portfolios of web services. What we wanted to do, first of all, we had to develop the central service where everything would end up and the front end so that users can go and navigate through this. And then we had to develop the pipelines that would bring the data from the research infrastructure to the dashboard. So the RIs have the responsibility of creating and supporting these pipelines. So they have the web services, and then they have to fill in, they usually call it a YAML file, so a metadata file, where they give all the information that the dashboard needs so that it can retrieve the data and visualize them on the front end. So basically, the responsibility, as I said, is always on the research infrastructure. But then we do have the central service with the back end and the front end that will support. I mean, if you want more technical details, definitely we can ask. We have the main developer, Raul from EMSO. So he can explain how the central service works. And we also have Cherk from Maris, who can explain how one of the research infrastructures have implemented these pipelines.
Great, thanks very much. And we have one final question from our colleague here.
So thank you very much for these very interesting presentations. I had a kind of curiosity question for Miguel. What sort of research are researchers from cultural heritage doing in your labs, just out of curiosity? And for Angeliki, I was wondering if, because I understand these are use cases, maybe they are prototypes, but I was sort of exploring on the dashboard, and it seems there's only a selection of sampling places. So I was wondering at which stage of development are you, for example, if I want to have the data for Madrid, or can I aggregate data, for example, using also standard statistical units like nuts, for example, and what are the plans for future steps? Thank you.
Okay, so concerning your question about cultural heritage, there are several applications. In particular, this is a lot using X-rays. You can imagine as a very powerful X-ray machine. So, for example, to study pictures, see what was behind. To study, it has been used, for example, to study Egyptian sarcophages or artifacts without opening to see what is inside. Nowadays, the same thing is also done with neutrons. I mean, we have the limitation that the neutron flux is much smaller, but we do the same kind of things. And there are also other less obvious applications, like, for example, studying swords or metallurgic artifacts. So, for example, scanning the surface of the object to determine how it was, for example, the lead was melted, or basically there is different diffraction peaks depending on the strain and the stress of the system. So these are, for example, two of the applications to the cultural heritage field. Yeah.
And for my question, the question was at which stage we are now in the development of this dashboard, and if we plan to do basically improve the service. So for the EOSC Future project, the dashboard will not change much because we are reaching now the end of the project. We have to maintain the service for how long the extension of the project is going to be. And of course, it will continue running as long as we have the research infrastructure supporting everything. First of all, thank you very much for already taking the dashboard, and it is really important for us to receive feedback. This is true. We only have a collection of these indicators now. We have a couple of indicators coming from each of the research infrastructures. And those are provided by the partners that participate in this project. But because we have set up the architecture to be, as I said, flexible and as simple as possible, we would like to see also how to integrate, for example, data from social sciences. So we have research infrastructures also from social sciences in the EOSC Future project. We have discussed this. We would like to experiment with a few things. What you mentioned about choosing a specific location, this of course depends on how these indicators are provided. So we will have to add different parameters, and we will have to see, for example, if we can provide these location parameters for all of the indicators and then bring this up at the central level. So for the EOSC Future project, we will not go that far. But of course, we have created all the foundation, all the basic architecture that can be improved further. The research infrastructures that provide the data, as I said before, they create these pipelines, they have their own systems, so they query different databases, they might create uniform data sets and stuff. So the technology is there. We just need to have the time and the funds to continue. Thanks.
Great. Thank you very much for this exciting discussion, and many thanks to Miguel and Angeliki for their presentations. Now we're moving over from research to innovation and business, and Marcin will lead this session.
Okay, thank you very much. Right, we are moving to the business part, and that is equally important also in the future. And basically, I'm representing Poznań Supercomputing Networking Center, but first of all, EOSC Digital Innovation Hub. Within EOSC Digital Innovation Hub, we, for last couple of years, like 6 years, we are collaborating with the companies currently. only in EOSC Future, we were running over 30 pilots with business pilots with the companies. So today we will show you 2 of such examples, but there is much more. So I invite you also to visit our webpage to see what is the offer and how we collaborate with the private sector, together with our partners from different projects that are also represented here. So basically, currently the community, it is over 80 companies that are in the Digital Innovation Hub community. So it's quite a number of really different kind of sectors and domains. And today, what we will show are 2 examples, the demand side and supply side. What does it mean? So one of the examples is on the really amazing pilot that came to us and said that they want to exploit EOSC services to create new innovation and basically to create new services, right? And so this is the demand side. Also, we had chance in EOSC Future to do also kind of supply side. So one of the research community, so we've done such kind of questionnaire, and what we got is a kind of requirements toward developing the new software by the companies for the research community. So this is the supply side. So with this very long introduction, I would like to introduce you to Rory McNeil, that is from the airspace, and it's really one of the greatest pilots we have, and this is about the airspace and integration with the Zenodo and Argos. So, Rory, the floor is yours.
Thank you, Marcin, for that generous introduction. Let's just see if this works. It works, great. So I realize this is going to take a bit of more than a bit, a conceptual leap to move from science workflows to thinking about tools which support the workflows, which are more generic. So it's even a bit of a leap for me, but I imagine it's a bit of a leap. So thank you for hopefully for bearing with me as we go through this. So I'm going to do 3 things today. I'm going to tell you a bit about our space, the problem that we're addressing, how our space provides a solution to the problem. Then I'm going to talk about the DIH project, which Marcin mentioned, which involved integrations with Zenodo and Argos, and then how the integrations enhance the RSpace solution. So what's the problem that we at RSpace are addressing? The research data lifecycle. I imagine there are various depictions of this, which many of you, everyone here probably is familiar with, various phases of the research data life. So that's the context, if you will. So what's the problem? The problem is that at each phase of this life cycle, in fact, I'm involved in an RDA group right now, which is trying to map out the different tools which are used at different phases of the life cycle. That's a separate project. But the lack of data-centric research tools leads, and lack of interoperability between the research tools leads to siloed data, and that impedes FAIR. It also creates friction for researchers. So there's no solutions, there's no easy solutions, but the notion of a research commons is becoming quite widely discussed. And it was, for example, I was at the Cordy conference at the NFDI conference last week, and certainly they're thinking about a research commons. A lot of the things we heard about this morning are also research commons kind of concepts. So I think Scott Yokel, who's the University Research Computing Officer at Harvard, has a nice definition of what this could be, which is if we could bring together data with cloud computing infrastructure and commonly used software, services, and applications for managing, analyzing, and sharing data to create an interoperable resource for a research community. I mean, that's what EOSC is all about, right? So there's lots of different concepts of research commons. Many of them are kind of domain focused, but I think there also is the possibility of a more generalist notion of a research commons. So it's quite interesting if you look at the EUDAT's collaborative data infrastructure. What are the core components? Well, there's repositories, there's a data management planning tool, there's a storage capability, there's a provision for PIDs, and there's a provision for discovery. And if you look at some of the other, I don't have time to go into this today, but Canada's looking at something which is actually very similar. So this is the notion of a generalist research commons, which is a great idea. However, coming back to the problem is that in these research commons, the tools and services are not interoperable, generally speaking, which leads to siloing of data, hindering fair workflows. All right, so that's the problem. What's RSpace? So RSpace is a kind of designed counterintuitively to against the flow, if you will. It's a data-centric digital research platform designed to interoperate with and connect with research infrastructure and to be interoperable with other research resources. So there are 4 core components of RSpace, which you can see in the middle. It consists of what's classically known as an electronic lab notebook. Second, it's got a fully featured sample management system. Third, it supports this ecosystem connectivity with resources and tools. And fourth, it's got a set of APIs to facilitate extensibility. So again, there's no time to really go into this in great detail, but if you look at the light blue elements, you can connect from RSpace, which is where you document and write up your research, as well as with your samples, to big data resources where you might be keeping imaging data or sequencing data and make links to those as you do your research. You can also link to specialist tools like PIRAT, which is a colony management system, Cluster Market, which is an equipment management system, Omiro, I'm sure many of the scientists in the room know Omiro. It's an open microscopy resource. So if you will, there's support for research workflows. We also, if you look at the purple, we've got, and that's really the focus of the DIH project, we also have support for integrating research data management capabilities into research workflows. So we integrate with data management planning tools now, including Argos, which I'll talk about in a minute. And then at the other end, so you can associate your data management plan with the research output of your project. And then that can be exported to repositories, now including Zenodo as well. So that's briefly an introduction to RSpace. And this is a conceptual slide, if you will, to indicate how RSpace could interoperate with, in this case, the EUDAT's collaborative data infrastructure, acting as a connector, if you will. And again, to me, the goal of Research Commons, and indeed the goal of really everything that's being discussed at EOSC, should be to enable flows of data and metadata in a streamlined way throughout tools, throughout the research process. That really should be what we're trying to do. So let me talk a bit briefly about the pilot. So there were 2 aspects of the pilot. We had integration with Argos, which for those who don't know is a data management planning tool, and that's the first one. And these are just a few screenshots from RSpace, which show you how you can ingest a data management plan from Argos. You can search the data management plans that are accessible to you, upload it to, select one, upload it to RSpace. There's a special location in RSpace where the data management plans are stored. And then you can actually, as I said, you can link the actual data output from your project with the data management plan. So that's the integration with Argos. And the second integration, which is also integrated with the Argos one, is an integration with Zenodo. So this shows the other end. When you're finished or when you want to export your data, you can export your data to Zenodo to make it publicly available and support FAIR principles. And this shows a bit of the export flow. We also support exports to other repositories as well as Zenodo, so you can choose a repository, choose Zenodo, you fill in a bit of minimal metadata. And if you want, you can associate the data management plan in the export as well to complete that flow. So the Argos and Zenodo integrations, why did we do them? What did they accomplish? Well, they expanded the scope of the interoperability in our ecosystem, as I showed you. They enriched the ecosystem, and also I think they help enhance the value of RSpace as a core element of a research commons. And finally, what was the impact of the EOSC project? It doesn't seem like a lot, but actually when you think about it, it is quite a lot. First of all, it was actually through discussions with people at, with Marcia and others that helped us consolidate the idea. Secondly, they were very useful, very helpful in facilitating relationships with people at Argos and Zenodo. They encouraged us throughout the project. They're helping to publicize the project on completion, and I don't have a slide, but there is a user story, a success story, whatever you want to call it, somewhere. And also, they've been extremely helpful in providing broader support for research-based as a company. So, my heartfelt thanks. Thank you.
Thank you very much. So we move now to second presentation. Afterwards, we will have questions, right? So now I would like to welcome Jarosław Kurek, that is from CEF company, that will present basically the phenological analysis. Okay. So sorry. Okay. Just you can start, introduce yourself.
Na Google Drive jest nowa prezentacja.
Proszę?
Na Google Drive.
They are changing. So maybe in the meantime, we could have questions for Rory while we still will be preparing the slides. So are there any questions for our space? So, basically, I have questions. So, what's next? What are the exploitation plans? What are your next plans? So, how can you go? Yes, from now on.
Well, currently we're working on again facilitating interoperability and flows. So at the moment we're focusing heavily on PIDs, so incorporation of PIDs into RSpace and multiple and interoperability with other tools that are using PIDs. So, for example, making it possible to incorporate a DOI with an RSpace record, which then gets passed on to Zenodo, would be one example. Something we've just completed. We're also working with ontologies. So, starting with biontology as a proof of concept, you can now associate an ontology from biontology with an RSpace record, and this is even after the project. And then when the data is exported from RSpace to a repository, including Dataverse and Zenodo, the ontology that's associated with the data is also passed on to the repository and captured in their metadata fields as well. So those are some of the things we're working on. Yeah.
Okay. So and basically, how do you see further collaboration in the ecosystem?
Well, one of the things I was reflecting on this morning, it's very complex and I can't get my head around it at all, but there are the core infrastructure, the nodes, all these things, a lot of them are highly complementary to what RSpace has. So it would be nice to think that there's a way for RSpace to plug in to some of these things. How I even go about exploring that possibility, I don't have a clue. So if anybody has any suggestions, I'd be grateful to hear them.
I'm afraid I don't have any suggestions, but I do have another question. I'm curious to know this new functionality that's been built as part of this work with EOSC Future. Is this now available for end users? Are they benefiting from this? It would be nice to have some testimonials or something if this is the case.
Yeah, at the moment we have an enterprise version. We also have a free community version. Sorry, at the moment we have it. Yes, we have an enterprise version. We also have a free community version. So yes, they've been released, and also we're in the process of transitioning to going open source as well. So from early next year, you'll have the ability to download and install your own RSpace version. So yes, it's already available.
Okay, one more question and when we move.
Yeah, so actually my question was related is whether it can be accessed and used directly from the EOS portal. So now that people are being enticed to start using the EOS portal, create their own profiles and start sort of integrating services and tools and data from the EOS portal, is RSpaces actually usable directly from the portal or
not yet. Matti, if you know Matti, everybody knows.
Yes,
Matti has been just thinking about helping to advise us about how to get onto the EOS portal. But so we'd like to, but we're not yet, no.
Okay, so Research Data Alliance, Matti.
Yes.
Yes.
Yeah.
Okay. Maybe there's another
Okay,
Matti.
thank you again. Okay, and
There's
now
only
we
one
move
Matti.
to, Jarosław. Okay.
Thank you very much for the invitation. My name is Jarosław Kurek. I'm part of the set of the software company. And my presentation is maybe more focused to AI, artificial intelligence, because I'm taking care of this part of the system and the project. So this topic is about the software service, image analysis in the phonological research enhanced by AI methods. Together with the Poznań University of Life Sciences and set software company, we together created some project for the marketplace. So I show later how it looks like. So as I mentioned, my domain is AI and IT. So sorry for maybe I can't answer the phonological research questions, but maybe another question will be arise. So we'll see. Additionally, I working at the Warsaw University of Life Sciences, and I head of the AI department. So if someone has any AI questions, so maybe after that, so we can talk about this. Okay, so this project was founded by the Digital Innovation Hub, so DIH. So this is the tender. This was a tender, and exactly the tender was under title the purchase of software services for image analysis in phonological research with implementation, licensing, support, and maintenance. As I mentioned, has been developed with Poznań University of Life Sciences to meet their needs exactly. And community. So what are the needs? So domain of the interest, generally as you can see, the head of the problem was that in the domain of phonology domain. So this discipline is studying the vegetations and temporal changes. So this is the main idea. And the targets seasonal events like budding, flowering, fruiting, and aging. And we try to apply the AI for these events, and in automatic ways to support this. So collecting some flowering parts of the images, fruiting, and aging some stages. So generally offers insights into the state of our landscapes, vegetations, cover influenced by environmental factors and human activities. So after this AI results, we can do some analysis. So we will see later. And in relevance in the context of the climate changes, so critical is understanding the health and the occurrence in the plant spaces. So generally we focus on the two spaces, so Apis and linden, but it is only examples. So some of the pilots, let's say spaces. So exactly we try to fill the gap. And we propose a solution, as you can see, using the machine learning some algorithms, and of course, machine learning algorithms without some data was nothing. So we should have some collection of a lot of images for training, and of course to create some models, AI models, to be used in this project in the platform. Exposed by marketplace. Okay, so generally this is the first, let's say, maybe this is not the landing page, but this is the login page. So this is the all required logos, let's say. And main functionalities, this is only the 2 slides about the main functionalities. Based on the rest of the slides is all these screenshots to show you how the software looks like. So the main functionalities on the platform so include the generally, as I mentioned, linden and apples. It was species, so images was collected for these species, linden and apples. So with automatic way or from the camera, using some scheduler, or you can manually create the data sources from your own data sources from local computer or the Google Drive, and we can apply on the system, on the web system, let's say, the web application, some already prepared AI algorithms. And then after when we achieve our results from the AI, we can do some statistics and statistical analysis, and do something with this, create some charts based on the results of the AI models. So generally, so we have the three AI models. So based on this algorithm, which is in the brackets. So it's one of the mask RCNN is one of the top, let's say, the state of the art of this for this semantic segmentation. So generally, the idea is to find, for example, apples in the all apples in the images. So for example, in the orchards, or and it is a semantic segmentation. So it is not the object detection. As you usually maybe you came across, the object detection is only when the apple is in the bounding box, in the rectangle. But semantic segmentation is a little more difficult, because it is inside the rectangle box. You can find any pixel, if any pixel belongs to the apple or not. So we can, so it is more difficult to find the apples and create the mask. And for the linden, it is classification. So we try to recognize which linden is flowering or not. And of course, we can use the same algorithm for find the linden on the image and create the mask for this to create ROI. So it is region of interest. And some of the screenshots from the system is only a few, because it is probably there's not enough time. But if someone is interested in this, I can show you later. So this is our location when the camera currently is cameras are located. So and my in the worst of it is the test image sources. And this is the screenshot how we can see the image sources and some metadata. The camera was static, so it is, as you can see, the metadata was created manually in this way. Some coordinates. Based on coordinates, we can find the nearest weather station, and of course calculate the sunrise sunset based on the coordinates to find if the image is well exposed or not for later AI analysis. Some of the images, it is only the thumbnails on examples to see what we have in this data source, and some of the model for the processing. In this case, it is linden, so classification model or segmentation with we can create some ROI, so it is region of interest. For example, you can use this like this. This is for example, in this image. For me, when I'm not part of the phenological research, and someone told me that this is the linden, I was shocked, because it can be this one for me. It doesn't matter for me, because I'm technical, some AI, so IT, so I don't know where is the linden. So I was shocked that my algorithm, we should find this one. But of course, this is only example that's how to create the ROI. So in this previous slide was with the polygon, but we can create another so only to. But what for? That we from the linden this, let's say, ROI, we take into the consideration that is flowering or not. So in the images, so So the AI try to focus on this area only. Okay, so this is when the AI algorithms find the linden or the many apples inside of this image for the orchards, for example. Based on this, we can create some statistical analysis, as you can see, and some of the visualization, for example, RGB, and a lot of analysis, but there's not enough time to show you most. And of course, data, we can combine data from weather station, and of course with some RGB or another statistic indicators, phenological indicators. So, and this is the result of the how to find algorithm AI. AI algorithm finds automatically region of interest for the linden. So, for example, this is automatically found. So why is this a little different? And this is only probably the last slide. This is for example, image for the orchard, and the idea and the aim of this AI it is to find the apples, all apples in this image, and this is the results, let's say. And we create the statistic based on this founded apples inside. So that's all.
Thank you very much. Thank you. So 2 quick questions. Anybody? Not online, from the room? Okay, so my question is this available for scientists? And how they can access it?
Yeah, so this platform is available for registered users, and if someone wants to be registered, wants to be a part of the system, let's say, they need to create the account. Account should be generally verified by some group of administrators. So to make decision that this is not the bot, let's say, but it's, let's say, some researcher, the real researcher, not the bot, and of course they approve the account for the access.
What about software? Is it available?
Yeah, available.
Yes.
It's public. Yes, it is public. It's available currently under the link of probably the first slide or the second. I don't remember. So probably in one day it can be available. Account will be available after approval.
Okay. Any other questions, please?
Are citizen scientists able to contribute to this?
Scientists?
Citizen scientists, like, or not?
Yeah, so generally it is for, as I know, it is for let's say, European probably citizens, so, so we can...
Yeah, you can, on top, I think, build different cases, as I understand, and you can or use service, or you can take up software, instantiate, and add new cameras and work on it. So yes.
Great.
Okay, so thank you very much. Thank you again. And so just last final word. So if you are interested, there are just 2 examples here for how we work with business. If you are interested in collaboration with wider representatives of the private sector business, just contact me and we'll make it happen. And again, thank you for these great presentations, and that's the end of the session. Thank you very much.